Hi guys, Buildzoid here, and today I'm just going to be talking about some overclocking that I've done for the Corsair DDR5 Invitational competition, because I got invited to this, along with, I think it's 20 other overclockers. Is it 20? I don't actually know how many people are in the competition. My main concern is to not be last, so that's kind of that, because this is a, we've got some, some really top overclockers here, right? Like, the main reason I'm included is because I have a YouTube channel, not because I'm particularly good at memory overclocking. I've literally, until this competition came along, I've literally not run DDR5 on liquid nitrogen at all. In fact, I've not run a 12th gen CPU on liquid nitrogen until this competition came along, because, yeah, I just sort of wasn't a priority, let's just put it that way. Not that I wouldn't want to, it's just, um, wasn't a priority. So, anyway, really, the lineup for this is ridiculous, because we've got Alex at row, Bob NZ, Bullshooter, me, Crazy85, Firekiller GR, Lucky Noob, Lumi. Lumi has a YouTube channel, by the way. You should check him out. He makes some pretty good, actually, well, he makes a lot of extreme overclocking videos. Uh, and then we've also got Miller, Nolisso, Ralph, Sergman, Splave, Unity of Saints. I think Splave right now is ranked second in the world. Ralph, I think, might be fourth or something like that. Actually, let's just check. Let's just check the rankings right now. Yeah, so we've got first place, second place, Ralph. Safe Disc works at Asus, so he's obviously not invited. Sixth place, yeah, Miller, Unity of Saints. So yeah, you can, and I think if we scroll down a bit further, Alex at row shouldn't be too far behind. He used to be a few years ago. He was, yeah, he's still in the top 50. So meanwhile, I'm all the way down at 106 or something horrible like that. Yep, 106 right there. That's me. Um, anyway, so yeah, my goal for this competition is to basically not come last, because this, we've got a lot of very good overclockers in it. And the main reason I'm included is because I have a YouTube channel. So here, fulfilling the obligation. Anyway, yeah, so right now I'm in first place, actually, but the main reason I'm still in first place is because there's 11 days left in the first stage of the competition, and so nobody has posted, the really big scores yet. Yeah. All the big scores are probably going to come in the last 2-3 days, actually, probably even the last day of the competition. And so I'm gonna probably very quickly slide down to last, if not second to hopefully second to last, because I don't want to be last. But yeah, I do not have high expectations for me doing well in this, because I'm really not that competitive. That's kind of the thing, is if there's some, for a lot of I'm the kind of person to run SuperPi 32 million on Windows 10, just because I really can't be bothered to deal with Windows XP. Even though Windows XP is significantly faster, it's nah, I am running Windows 10, because that is way more effort than it's switching to XP is just not worth the effort, in my opinion. So that's kind of the thing, is I enjoy overclocking. But I enjoy the make things go faster part. I do not much care for the getting the OS dialed in and stuff. So that's why when people ask me for an OS optimization guide, and it's I'm not doing one, because my OS is not that great. And that's also one of the main reasons I prefer GPU benchmarking, because in GPU benchmarks there's less stuff to do. For at least the ones I like to run. There's some old ones where there's all kinds of weirdness that it's just yeah, and that's why I don't run them. Anyway, so for now I'm in first place. I'm also the only person to post a score on LN2 so far. When I was still on water cooling, I was getting, actually I have the water cooled score right here. Yeah. So my best result, so right now I'm in first place with 6 seconds and 761 milliseconds to complete PYPrime 2 billion. PYPrime is a pretty memory latency sensitive benchmark from what I can tell so far. And it's very light. It runs on one thread. It's very quick. I like it. It's a nice benchmark for memory overclocking. So also there's a restriction in the competition for like to keep the CPUs at 5.5 gigahertz, and this is just to make sure that you know, the memory is actually doing the heavy lifting, and you don't get into first place by running higher CPU clocks than everybody else, because it's a memory overclocking competition, not a CPU binning contest. Though binning the CPUs for the memory controllers would still be very helpful in for a competition like this. And of course, I'm just running the same 12900K that I've always I use all the time, the kind of terrible one. So um, yeah, though I don't think that I don't think is a really great, like, I don't consider that a good excuse in this scenario. Um, yeah, we'll see. Like, the thing is, like, PyPrime, I've literally never run this benchmark until this competition came along, so I have no idea if there's like big mistakes that I'm making with it. Which there's, and if I am, I'm not sure that I'll be bothered to fix them. Um, Anyway, so yeah, so right now with liquid nitrogen, I'm in first place with 6 seconds, 761 milliseconds. On ambient cooling, this was the best result I was able to get, which is 7 seconds and 71 milliseconds, which not really that great. Yeah, that would literally put me just before last. Though, yeah. Um, I imagine if Crazy 85, yeah, Crazy 85 is a name I recognize from, like, he definitely overclocks with LN2, so I'm coming dead last. Yep, that's great. Oh well. Anyway, um, yeah, so that's kind of how the competition itself is going for now. But since we're benching PyPrime, I sort of noticed that the record for PyPrime on DDR5, why don't the pop-ups go away? There we go. Um, yeah, since we're benching PyPrime on DDR5 for this competition, I sort of noticed that the best result for DDR5 memory in PyPrime was within reach, right? Because like my current best results for this competition, which is limited to 5.5 gigahertz, is 6 seconds, 761 milliseconds, and the previous record for PyPrime on DDR5 was 6 seconds, 713 milliseconds, and it's like, and this is, you know, from safe disk at 6.8 gigahertz on the CPU, the cache doing 6 gigahertz, so like massive CPU clocks. And I'm, you know, getting almost the same result at 5.5 gigahertz. So I was like, I think I can beat that. And turns out, yes, I can. The thing is, PyPrime is not like a benchmark that currently gets points. So the competition for this, for PyPrime, is really not that. It's not that competitive. Like, there's just, yeah, not this benchmark doesn't get that much attention. So it's not really that surprising that, you know, I was able to take first place. I imagine after this Corsair DDR5 competition is over, it's going to be a lot harder for me to get a good results in PyPrime over, like, outside of the competition, because this isn't for the competition. Anyway, basically, at 5.8 gigahertz with pretty tight memory timings and actually kind of a miserable memory speed, I got 6 seconds, 704 milliseconds beating safe disk. And the reason I did this was just like, well, I already have it set up for PyPrime anyway. I could just clock the CPU like 200, 300 megahertz higher, and I can probably beat safe disk's score. So I did that. Yeah, turns out, because safe disk is running, like, PyPrime really seems to be more about memory latency than anything else, and SafeDisk is running basically Geekbench settings on his memory. Like, if we zoom in on this, like, yeah, this is Geekbench, and the biggest difference I'd say is probably the 2T command rate compared to my screenshot, because I'm on 1T, 28, 38, 38, and also all of my timings are slightly tighter. I don't know about tertiaries because obviously we can't see them here. And like secondaries, I have no idea what's going on with his. But yeah, basically, because the benchmark cares more about latency than bandwidth, having memory settings like this, which are really dialed in for memory bandwidth, doesn't really do much. And so, you know, at 5.8 gigahertz on the 12900K, I am able to beat a 12900K at 6.8 gigahertz, which is a good demonstration that PyPrime is actually like a good memory benchmark, because you want the memory to be more important than the CPU. And so evidently the memory is way more important than the CPU, because otherwise, yeah, I shouldn't be anywhere near first. Like I shouldn't be able to beat SafeDisk's score. Um, anyway, so that's sort of something I did for fun as part of the competition. So that's the results. Let's take a look at what I was actually benching. So for the motherboard for this competition, I decided to use the Tachyon. Here it is in its dipped glory for LN2. Now the thing is, I have a ton of Blaze Orange Plastidip, because I like the color orange. And what I've figured out, and unfortunately, one of the biggest problems with a lot of the colorful Plastidips, if you're trying to use them for insulating, like for LN2 overclocking, is that they don't stick to PCBs that well. Black Plastidip works great. Because black Plastidip is basically liquid electrical tape. The clear Plastidip also works really well. Red Plastidip also tends to work very well. And then a lot of the colorful ones, like I've tried blue. Blue has liftoff issues. Orange has liftoff issues. Blaze Orange has liftoff issues. Yeah, basically a lot of the more colorful Plastidip options out there have a tendency to just sort of lift themselves off the PCB as they dry. And the easiest way to work around that is to apply it really, really thin, which makes it an absolute nightmare to remove. But I have so much Blaze Orange Plastidip that if I ever want to peel this off, I'm just going to apply another layer on top of it, and it's actually going to start lifting itself on its own. So that'll make the peel very, very easy. So yeah, that's why the board has like a ghostly layer of Plastidip. Though to be completely honest, I do think this kind of looks kind of neat because you can still see all the components instead of just having like a solid black motherboard or something, which is what you get if you use like black Plastidip. Also, I don't recommend if you're insulating with liquid electrical tape or Plastidip for LN2 overclocking, I really don't recommend that you try to spray it on because in my experience that doesn't really work very well. Like you just don't get the coverage you need, and basically every motherboard that I ever tried using like sprayed on insulation would inevitably end up having weird like issues after like an hour or 2 hours of runtime. Whereas what I do for this is I just use a paintbrush to, paint it on. And with this kind of application, like I literally had ice all the way to the 20. Like actually, I had ice all the way to the 24 pin with the chipset frozen over, and the board still ran fine. In fact, like that, and the funny thing is, I don't actually have it properly insulated under the chipset, so that's something I'm probably gonna revise before the next session. Because the top score that I have for PYPrime right now is actually not the fastest I've done. It's just the one with like the best memory settings, right? So for the competition, what I submit is this 6 seconds 761, and this is at like 3740 megahertz memory clock. So that's 7,480 megabits per second effective, 28, 39, 39, 28 1T command rate, and the thing with this right here is like, so these are like the best memory settings I've managed to run with 1T command rate and like, yeah, best memory settings. However, I have a very slightly faster result, which is at like 7320 megabits per second, and yeah, slightly tighter timings. But so I decided to post this result to the competition and not this one because I'm pretty sure, like, the issue is with this one, I wasn't like, you need to rerun this benchmark a few times, and I didn't do that for this result right here. So this was like, oh, this is like one really good run, and then I tried to raise the BCLK again because I was like, oh, what if I could run it at 7500 instead of 7480? And well, 7500 blue screened the system. Yeah, so that's kind of that. And at that point, I sort of decided to try messing with the other BIOS I have on the board just to see how that behaves. So yeah, in the like definitely like I think I can probably push under I can definitely beat this. I can definitely beat the 6758. I would imagine that like the top scores for this competition are going to be like in the 6.6 range, if not 6.5 range. So I expect to get absolutely destroyed. So anyway, where was I going with this? Yeah, so like I've done 2 sessions so far. So this is like session number 2, session number 1, and during session number 1 I kind of realized that the cold is kind of getting places where I don't want it, so I extended the plasti dip to like this area and a bit like all the way to down to this M.2 slot and a sort of around the chipset. And I figured the chipset would produce enough heat to keep itself from freezing over, but then session number 2 came around and I had the CPU all the way down at full pot. And I'm not using a backplate like a motherboard heater or anything because I want to keep like I'm running the memory on LN2 as well, and so that was kind of pointless because the whole like this whole side of the board is going to be completely frozen anyway. Um, and so with the CPU at full pot, it turns out after a few minutes the chipset freezes through. So I'm gonna have to like insulate probably all the way down to the connectors down here because yeah, like the cold just goes. It's a 10-layer PCB, and I guess there's just a massive ground plane going through one of the layers that just goes everywhere. And so once the CPU is cold, everything gets cold. USB ports get cold. Yeah, the PS2 port especially for some reason gets really bad condensation on it. So um, anyway, but the board ran for like I don't know. I don't really time my sessions, but it ran long enough that I got bored of it before I had any issues. Let's just put it that way. So the insulation did its job. It's not peeling off. Well, actually, there's a little bit of lift off around these capacitors over here, but that's fine. That's not the important side of the capacitors. Um, like the main concerns I have with insulation is like power stages, making sure those are well insulated. Because if those aren't well insulated, if you have like 12 volts get like condensation connects your 12 volts to something that isn't supposed to be 12 volts, very, very bad. Really, really bad. So, yeah. Anyway, that's the board as it's set up, as I have it set up. The memory, well, I guess I'll show you what it looks like after it's frozen through. So, actually, let's just do a setup picture. There we go. Yeah. So this is a picture from the most recent session that I've done. I'm using the Elmore KTH thermometer. This thing's super convenient and also like way cheaper than buying like bigger real thermometers. Like the nice thing is like big screen, small. It's very fast, which is another like useful thing to have for LN2 overclocking. So yeah, great little thermometer. And that's handling both the memory temperatures, which the way I'm measuring the memory temperature is I actually have a bit of thermal pad sandwiching the probe between the memory sticks. So that's not a very accurate temperature measurement, but as it turns out, I also have massive issues actually transferring like heat from the memory sticks to the LN2 pot for the memory. So what tends to happen is the memory, like I end up running the memory at full pot, but the memory temperature never goes below like minus 120. Well, it doesn't go below minus 120 until I freeze the CPU through, and then, the CPU sort of indirectly starts cooling down the memory sticks even more. But with the CPU at minus 140-ish, it's basically impossible for me to get the memory below minus 115, 11, yeah. So that's kind of that. As you can see, we have just frozen over all the way to the edge of the board. And this, I actually had to defrost this a few times because so basically the X3C BIOS is best for PYPrime because PYPrime primarily cares about memory latency. But the other BIOS that I have on the board is the F4 BIOS because that BIOS gives me really good results for 2T command rate and should be really good for something like Geekbench. Or other like bandwidth heavy memory benchmarks. But the thing with the F4 BIOS is it doesn't have support for Gigabyte Tweak Launcher, which is basically the Gigabyte tuning, like in OS tuning utility that doesn't suck. EasyTune is a horrible pile of trash. I don't know why they don't just release the Tweak Launcher for all of their boards directly. Anyway, the F4 BIOS doesn't support Tweak Launcher, so that makes life kind of difficult, and I needed to use the bclk buttons. And the thing about the bclk buttons is they freeze over. Basically once the bclk button looks like this, you can't press it anymore because it's internally frozen. So basically, every time I wanted to change the bclk in the OS, I'd have to slightly defrost the corner of the motherboard, change the bclk, and then just yeah. So that's been great. I really wish I had more modular heat, like just heating strips that I could just put under this edge of the board and then maybe like a line, like an L shape basically around the CPU and the memory. Because I don't actually want to heat up like the PCB under the CPU and under the memory, but around it so that the cold is contained to the CPU and memory area. But either way, this like it turns out I don't really need to use the F4 BIOS anyway, so that's like for PyPrime I don't need to use the F4 BIOS, so that's just kind of whatever that this all freezes over. Though if we have a Geekbench stage, then I guess I'll have to have the hairdryer just pointed at this side of the board permanently, which is going to be really annoying because I'll have to improve the insulation on the memory sticks so that they don't get heated up from the hairdryer blowing hot air onto this side of the board. Anyway, yeah, so that's what it looks like kind of in action. Oh, and I have a fan for just handling the cold LN2 vapors to try minimize how much the board is freezing through, but yeah, this edge of the board is like, there's nothing I can do about it. There's just no, like, the memory sticks don't produce a lot of heat. The voltage regulators in this area don't produce any heat. And so the whole thing just turns into a block of ice. And that ice slowly creeps towards the 24-pin and chipset eventually, which is why you can see like water droplets on the chipset heatsink, which yeah, I'm gonna be insulating the whole board, I guess. Um, anyway, so that's what it looks like when it's running. Oh, and I guess I should have mentioned when I said full pot, that means taking the CPU all the way down to minus 190 degrees Celsius. Anyway, Corsair provided the memory sticks for this competition, of course. They sent each competitor 4 of these memory sticks with this lovely engineering sample label on them. These are SK Hynix, which is the version 5.43.13. I'm not sure what the 5 the 5 stands for SK Hynix, but the 43.13 I have no idea what that means. Yeah, I'm not sure. Like, so for DDR4, there was a specific way the version labels worked, at least for SK Hynix sticks and Samsung sticks. But for DDR5, I have no idea what's going on with this version number. Yeah, anyway, these sticks use a 10-layer PCB, which is kind of neat, because a lot of DDR5 currently just uses an 8-layer PCB. Though, at ambient, I couldn't really tell I couldn't really see an advantage to the 10-layer PCB compared to 8-layer PCBs. In fact, I was really struggling with these sticks that was more the X3C BIOS, because, yeah, like, I was trying to run the X3C BIOS with 2T command rate. It really doesn't like that for some reason. And so, yeah. Anyway, so these are the sticks that everybody was sent. The reason why we all get sent 4 sticks, even though basically for every benchmark, like I'm assuming there's going to probably be a memory speed stage, and then we're only going to be on 1 stick, unless they want to do a 2-stick speed stage, which would be kind of weird. But yeah, like ultimately the idea behind sending 4 sticks is so that everybody can check it, like how good the sticks are, and then use the 2 best sticks that they get. Sort of reducing the role of the Silicon Lottery in the competition. And yeah, and I don't really have, like, I've not tested a whole bunch of DDR5 yet, so I don't really have much of an opinion on if these are, like, the best DDR5 sticks I've ever used, or if they're just kind of, yeah, because in total right now, I have 6 SK Hynix-based DDR5 sticks, and I just can't make a judgment on that. I will say I appreciate that these have power management ICs that actually measure voltages that respond correctly to voltage settings. Because the Gigabyte sticks I have, they have like a negative voltage offset when you start running them in like the extended voltage range, which is really dumb. These don't do that, so that's kind of neat. But I imagine that might just be an oddity of the power management IC that the Gigabyte sticks use, and hopefully that issue isn't that widespread, or maybe it is. I don't know. It depends on how common the Renesas power management ICs are. Anyway, so that's the sticks that we're using. And I guess let's take a look at the LN2 pot. So I've never run memory on LN2 properly before, and so consequently I don't have a memory LN2 pot, or at least I didn't have a memory LN2 pot until I built this thing. This is a 3mm copper plate. that's 10 by like 4, yeah, it's 10 centimeters by I think 4 centimeters. So it's just wide enough to cover up 4 memory sticks. And I literally measured it out by putting a copper plate over the DIMM slots of a motherboard and then just drawing a line where it needs to end. Um, yeah, so this can cover up to 4 memory sticks. Obviously, for this we're just running 2. Um, and the like extra bits of like soldering braid and random bits of copper, like like sheet copper inside, is just to add some extra surface area and mass. I don't really think it makes much of a difference. The thing is, RAM really doesn't produce that much heat. So yeah, like honestly, if I just left this as a flat tub, it would have worked probably just as well as it does with all this extra stuff in the middle, because yeah, like RAM really doesn't produce a lot of heat. And then there's just some copper, like sheet copper, soldered onto the sides of this 3 millimeter thick copper plate. And this works really well because for memory cooling, you basically just need to keep the LN2 in proximity to the memory sticks, and that's about it. In fact, the main issue I've been having with this is the thermal pads that I've been trying to use just keep failing on liquid nitrogen, like quite spectacularly. I did not know thermal pads could shatter, but apparently they can. So yeah, that's been the main issue, is like finding a thermal interface material that like will connect to the memory sticks, because the thing is I don't have like aftermarket heat spreaders for memory sticks, because again, I've never run memory on LN2, so that's just not a thing I have. Um, and so I've just been kind of resting this on top of the memory sticks with a thermal pad under it, and this thing just destroys thermal pads. So, or more like the LN2 destroys the thermal pads. But yeah, so that's the main reason I've not been able to get the memory below minus 120, is like this can very easily go very cold. And it does not leak, which is the sort of two main requirements. And then the thermal pad fails, and there's no thermal transfer to the memory sticks. So yeah, I'm not sure. Well, I might end up just like putting Cryonaut on the top edge of the memory sticks, which is going to be horribly messy, but at least that won't fail. Like Cryonaut like shouldn't fail like thermal pads do. So hopefully that'll let me run the sticks cooler. Because yeah, the thing is, like right now I don't even know what the optimum temperature for my memory sticks is, or if there's a temperature at which they don't work properly, because I can't really, like, I can't pull them all the way down to full pot. There's just not enough thermal transfer for that. Um, so that's been kind of fun. Anyway, here's the base of it, because the top side looks horrible, but this is the side that if I had proper memory heat spreaders, this would actually make contact with those, and it would do a perfectly good job in that scenario. Um, so, yeah. Anyway, um, that's the memory LN2 pot I've been using. And honestly, if you're thinking of making yourself an LN2 pot like this for memory overclocking, I highly recommend it. I actually made a second one for single DIMM applications, which is... So actually, how am I gonna... Okay, so this is the internal structure of it. All right, so again, we just have some like extra sheet copper that I had left over from cutting the sides, just soldered inside so that there's some extra surface area. Not that I think it will really make much of a difference. It's just kind of like, it looks weird when you have an LN2 pot that's literally just empty, like an empty tub. But this one is kind of like, the idea behind this one is it only goes onto single-sided memory sticks. So it's meant for like raw memory frequency, and that's kind of it. Like, this is literally only meant for max memory speed. So I really, really want to test this thing with like Hynix DJR DDR4. I also want to try it on some basically any single rank memory stick that I have. Like, the thing I realized about benching memory on LN2 is that like the RAM doesn't pull a lot of power, so it really doesn't use a lot of liquid nitrogen. And that makes it really fun because you get to, like, you get a lot of runtime out of very little liquid nitrogen, which is not true of something like GPUs or CPUs, which is like some CPUs burn through LN2 at an absolutely ridiculous rate, which there's no memory stick that's going to burn as much LN2 as a GPU or a CPU will. So yeah, I'm kind of excited about finally having these horrible monstrosities, because I can just sort of, whack them onto any memory stick that I feel like experimenting with, and it'll deliver cold, not optimally, but it will deliver cold, and that's really cool. So anyway, that's the top side of it. The way this actually connects to a memory stick is this contact surface right here. I guess I'll just have to put a bunch of thermal paste on that, or maybe thermal putty. Not thermal pad, because again, it'll just shatter once it gets to low enough temperatures. But yeah, the idea is you just sort of clamp this onto a memory stick onto the side with the memory chips, and bam, cold, very cold, because it is just one continuous copper plate all the way into the actual container. So yeah, and it's copper. Like RAM doesn't produce a lot of heat. There's no like this is about as direct as you can get for cooling single-sided memory sticks. It might even work okay-ish on double-sided memory sticks, depending on how well the cold travels through the PC, like through the memory chips and through the PCB of the memory stick. Um, and yeah, so this should be really really fun for like I really want to do it like run it on DDR4 DJR. That's the main thing I've been thinking about putting this on. But obviously, if we get a memory speed stage in this competition, I totally want to use this for that. Like that's why I built it. Is like this is for meant to freeze the crap out of a single rank memory stick. I just need an excuse to use it. Um, so yeah, that's this side, and this is what it looks like clamped onto a memory stick. I'm just using some GPU PC like I/O brackets because I have a lot of dead GPUs, and consequently, I have a questionable supply of useless PC like slot brackets, basically. And they're convenient. Like they're a nice piece of metal that you can just sort of bend into a shape, and then get whatever sort of clamping amount you kind of want out of that. Um, so yeah, because I just need the memory pot to not, fall off the memory stick. That's about it. Like I love RAM. Like RAM, like or more like, yeah, no, I love RAM on LN2 because it doesn't have all the problems that you have other than the thermal pads cracking constantly, but you don't have all the problems that you have with GPUs and CPUs, where like CPUs and GPUs, like you can't just use something that looks like this for cooling a GPU because it won't be cool. It'll just like it won't be cool. Um, so yeah, whereas with a memory stick, something like this is just going to freeze the absolute crap out of it. So, yeah, I really, really hope we get a memory speed stage, which is sort of typical for memory overclocking competitions to have a memory speed stage, so that I get an excuse to use that, the meme freezer solo, as I've decided to call it, solo, because one memory stick. The other one's called the Beam Freezer Quad, and I still have enough copper plate left over that I might make a 6-stick version in case I ever decide to put like x58 memory on LN2. Anyway, what else did I want to show you? Well, I've shown you the I/O, like the buttons freezing over. I have a bunch of screenshots. Oh, yeah. Also, the VRM on LN2 just freezes right through, especially for PYPrime, because like PYPrime's single-threaded, so it just doesn't pull any power at all, and so you end up with this. And then that starts creeping into the actual power connectors, which is why the power connectors get a little jacket so that they don't end up covered in water and corroding. Because I don't really think they would actually, I don't think they'd really short anything out. Freshly condensed water doesn't tend to be particularly conductive. But yeah, I still don't want like water in the 8-pin power connectors if I can avoid it. I have a picture of the... Oh yeah, here's a... So this is just kind of neat how when defrosting the edge of the board, you get this like it makes the board white instead of, right? Like, because when I wasn't defrosting the board, you just get this like snow layer on everything. And I just thought this looked kind of neat because it looks like the board is white when actually that's ice buildup that, like as it melts and then refreezes and melts, refreezes, it builds up like this really solid white layer. BIOS indication LED over there. Anyway, so that's kind of that. What else did I want to show you? Oh yeah. So the LN2 pot. So, well, let's just say here it is. So you may remember I made the video about the washer mod and how like 12th gen CPUs aren't very flat. In fact, they're bent in like the worst possible way for a CPU. They're bent, like the die portion of the chip is bent down because Intel's loading mechanism is cost optimized, not performance optimized. And that's the only, like, that's literally the only thing you can say about the loading mechanism is like, yeah, it's designed for cost, not performance. Because if it was designed for performance, it would try to somehow, like, I imagine you could just pin the CPU on the top and bottom edge, and then the center would end up being the tallest spot instead of the lowest spot. But anyway, I first noticed this issue on the like liquid metal water block that I use, but the thing is that water block isn't actually flat. That block is just relatively flat to compared to most CPU blocks. My LN2 pot, on the other hand, is really flat. Yeah, like that thing is basically, as far as like CPU cooling devices go, one of the flattest CPU cooling devices I have. So even with the washer mod, this 12900K is just very low in the center, right? Like you can very clearly see, like here we have a high spot, here we have a high spot, and then here we have a low zone because the freaking mechanism is pinning it down the freaking middle because designing it to pin it any other way would apparently be too expensive. Which is like, it is actually true. Like X299 has a loading mechanism that doesn't do this. But yeah, not LGA 1700. So that's super annoying because basically the only fix for this would be to even further reduce the loading mechanism pressure, and then probably lap the CPU because I'm pretty sure at this point the IHS of this thing is permanently bent. Which is a thing that happens to the 12th gen chips. Is like if you take a fresh 12th gen CPU, they tend to be relatively flat. Not perfectly flat, but not as U-shaped as they get after you install them into an LGA 1700 socket even once. So yeah, that's really great. And obviously I've had the CPU in a bunch of motherboards before I figured out the washer mod, and so that the CPU is bent AF, and consequently it makes horrible contact with an LN2 pot. So yeah, unfortunately, this is a Intel like review sample CPU, so I can't exactly go scraping off the markings on it because pretty sure I'm not allowed to do that. Which sucks because it's like if I was trying to bench, like for this competition, it's not really a big deal because PYPrime doesn't pull a bunch of power. But for something like Cinebench or Geekbench or X265 or other like big multi-core benchmarks, this is a disaster. This is an absolute, just complete catastrophe. Um, like this is so bad that like, you know, like most people think, oh, you lap the CPU, your temperatures come down a little bit. Like no, on LN, like for LN2 overclocking, this is costing CPU speed on multi-core. Like this costs, like straight up, this will lower the max clock of the CPU on multi-core workloads because it'll just get way too hot. So yeah, it's a good thing that the competition is about memory overclocking and not CPU overclocking, because with a thermal paste pattern like that, I don't think I'd get very far. I really hope we don't get a Cinebench stage. That would be really dumb. We won't. I'm 99% sure we will not be getting a Cinebench stage, because again, that would be really dumb for a memory competition. Anyway, the other stuff I wanted to show you is, you know, when I was on the 2T command rate BIOS, I did take this photo of a very high memory speed with like sort of reasonable timings. The thing is, it crashed when the reason I took this with my phone is I was raising the bclk and it just completely locked up. I was lucky that it didn't even get to a blue screen, because if it got to a blue screen, I wouldn't have been able to take a picture of this, but yeah, at 3900 megahertz, it was actually okay. It's like I was like, oh, can I do like can I do 4 gigahertz? And then nope, no, I can't. Maybe with even looser timings, but the thing is, this was really towards the end of the session. Like I pretty quickly realized that the 2T command rate BIOS for PYPrime just terrible, absolutely terrible. The scores it produces are horrendous. Because again, PYPrime is a latency benchmark, not a bandwidth benchmark, so all the speed in the world won't save you when your 2T command rate and trash timings get together and say hello to the benchmark. So, and refuse to give the benchmark its tiny little amount of data as quickly as it wants it. Anyway, yeah, and so since this was at the end of the session, I didn't go and like loosen out the timings to see if I could get 4 gigahertz going, because waste of LN2. Like, I only have 60 liters for probably the whole competition, and I don't really want to, waste it on screwing around. Like, once was like just for fun once, since I already had it up and running, sure. But the thing is, there's like a retrain hell anytime you have to reset the system. Where, well, it's not really a retrain hell, but basically, once you get into the OS, things are great. If you're not yet in the OS, things can go very badly very quickly. And if you're fiddling with like memory settings, just you need to like sometimes you need to retrain, and you can't retrain at full pot. So there's just like a whole bunch of like restarting is relatively expensive. Let's put it that way. It's definitely not the worst platform for like cold behavior. It's definitely more difficult than like 11th gen or 10th gen or FX, or by FX I mean AM3 Plus. Actually, just yeah, AM3 Plus in general is fine. Um, so yeah, so this is a bit fiddly. And so once this crashed, I was like, okay, that's that. I'm done. I'm not pushing it any further. But it was kind of neat that I almost did 8,000 megabits per second with timings like this. Like that would have been kind of neat, even if for PyPrime it's totally useless. Um, anyway, other screenshots. So I already showed you the absolute best result that I have, but I didn't post that because I think the memory settings are kind of lame. This result I did post, but I'm probably like, I basically need to rerun these settings and like figure out what is going on with my effective clock over here. Probably max the ring. I don't think 5.2 gigahertz ring is the limit. I'd like to do CL26, but I don't think it's happening at this kind of speed. Actually, that might be worth testing if CL26 at like 7200-ish. I think it would work at that range. Would be viable. Also, my tertiaries are screwed up. What happened is when I was making setting the memory settings, I accidentally set like basically I didn't read the like same group different group part of the timing, and so I set my different group and my different dimm or different rank timing. So I went one down too far in the BIOS because I wasn't reading the what is that? Well, the last two, yeah, I wasn't checking that I was setting the exact right timing. I was, sort of autopiloting it, and then yeah, so I set my different group and my different rank instead of my same group and different group. Different rank doesn't apply to the single rank memory sticks, which is what Corsair sent us. Also, they didn't send us dual rank sticks because dual rank on DDR5 makes very little sense, though that's a topic for another video, maybe. I'm not sure. Anyway, yeah, so basically though I don't really think the different group, like the same group, different group timings will really make much of a difference because I've already messed around with those before and they don't really seem to affect it that much. I'd like to maybe I'd like to try get the memory colder. Maybe try even more VDD voltage. Like I was running the memory with like 1.7 volts of VDD and 1.55 volts of VDDQ. To get to get CL28 working, and I think like at 1.75 it'll boot CL26, but it's like mega unstable. So I'm kind of hoping like either it needs to get colder or it needs even more voltage, which I kind of doubt will actually be an option. But going even colder is very likely to reduce the TRCD and TRP timings because those just straight up scale with cold. So as long as there's no like cold bugs or weirdness, yeah, if I can get the sticks any colder, that would be really cool. So I really want to rerun this, but like even more aggressive. So hopefully I can get like a 6700 or something, or something close to a 6700. Anyway, so that's the score I actually posted. For comparison, here's the fastest 2T command rate result I got. Also, like, not following the CPU frequency rules because, yeah, like I pretty quickly figured out that, like, 2T is terrible. Like, this, you can see it right here, right? Like, this is terrible. This is 100 milliseconds slower, almost. Okay, it's like 60 milliseconds slower with like 100 megahertz more core clock, 100 megahertz more uncore, and what is that? Like 400? Oh, and it's like 140 megahertz more memory clock. So yeah, like the 2T command rate and loose timings for Geekbench maybe, but for PyPrime absolutely no. Totally, absolutely useless for PyPrime. Also, it's worth noting that for PyPrime you want to have your hyperthreading disabled because hyperthreading adds memory latency. Um, just a fun fact. Not really a noticeable amount of memory latency under most circumstances, but if you're, pushing the limit of a benchmark where you're going to complain about like 50 millisecond differences, yeah, hyperthreading gotta go. And actually, I think it makes like 100 millisecond difference or something. Like, it's pretty significant. You don't want to be running PyPrime with hyperthreading turned on. Um, Anyway, so yeah, this is the best run that I got with 2T command rate, but still, like, it's pretty neat that, like, memory speed. Literally the first time I'm running DDR5 on LN2, so this was kind of cool. And it's, like, all 4 channels and everything, so yeah. The surprising thing about, like, DDR5 on LN2 is, like, the way I've been doing it is I, like, load up the... Well, at this point, I actually have LN2 profiles saved. But when I started out, like, I'd just load up the, like, air cooling and water cooling profile, or, well, ambient profile is the better way to turn it. So, yeah, I'd load up the ambient profile and then just change the memory speed and shove more VDD voltage into it. That was basically it. And, like, immediately you just get so much more out of the memory as the CPU and the memory cools down. So that's like, yeah. So DDR5 on liquid nitrogen, pretty cool. At least the Hynix DDR5. I don't know if like Micron or Samsung memory responds this well. I do have Micron sticks. I don't have any Samsung sticks. I guess I could try the Micron sticks or one of them, but I don't want to waste LN2 on that while this competition is going on. So, um, yeah, maybe in the future we'll try Micron DDR5 on LN2. I don't know what to expect. It probably sucks, because if it didn't suck, we'd probably see people running it regularly, but hey, who knows? Maybe nobody like, maybe everybody checked Micron and Ambient, was like, yep, this sucks, and then never bothered to touch it again. Um, but yeah. So that's it. Yeah, that's literally it for the um like overclocking that I've done for, well, everything that I've done for the Corsair DDR5 Invitational so far. Um, and I'm probably going to be last because everybody else is like actually good at this instead of just kind of doing it, or actually cares about being first rather than just kind of doing it for fun. Like, I've had a lot of fun. Like, like memory on LN2 is great, and PyPrime is a fun benchmark. I really wish it had points. And when I say points, I mean if you go over here, global points, hardware points, PyPrime, no points. I'm very sad about that because it's a really, like, it doesn't take forever. It's a memory latency benchmark, which are relatively rare because basically anything that's like an AVX bench, like multi-core AVX accelerated, probably going to end up being memory bandwidth limited, except if you're Cinebench. Cinebench doesn't care. But yeah, and then like the only real memory latency benchmark we have is like SuperPy 32 million, but SuperPy 32 million takes several minutes to run, and I'm very lazy, so that's not okay. And also SuperPy scales with the CPU a lot more than PyPrime does. So, yeah, cool benchmark. And memory on LN2 is great because it just doesn't use any LN2. Like I love that so much because, yeah, because benching on LN2 is fun, but like the biggest problem is like how quick, like especially GPUs just go through it so fast. And so now that I've done this, is like, yeah, I'm super tempted to just LN2 all of the RAM I have, just to see how it responds to it, because it's such a massive difference. Like, you go from, you know, like my best result ambient was this. We're like CL32, TRCD39, and we're doing like 7,000 and like 50 megabits per second for the memory speed. And then you go on LN2 and suddenly you're doing CL28, TRCD38, way higher memory speed, right? So, yeah. LN2 on RAM is cool. So, there. That's kind of it for this video. Big thank you to Corsair for actually putting on this competition. Hopefully, we see more of this, like more memory overclocking competitions. I imagine there will be also open ones, not just invitational ones, or at least I hope there will be open ones. Um, and yeah, that's it for the video. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, hoodies, you know, the usual YouTuber merch. Both Patreon and Teespring help out immensely with running the channel, so it would be much appreciated if you check them out. And that's it for the video, so thank you for watching, and goodbye.